All right, welcome back to day one of Unit 4. We were talking about surface area. So this is part 2. So if you haven't watched part 1, make sure you go and watch part 1. All right, we're on page 150. We're looking at activity 3 of this one, a practical domain and range. Han graphs the equation from the previous activity for the surface area of a cylindrical can with a volume of 452 cubic inches. All right, and you saw us write that just a little bit ago. All right. To see below. Actually, they are missing. Oh, and actually, let me go back to this. Um, I actually did write this incorrectly now that I see. Okay, if I go back to page 148, this should have been 2 pi. The pi's actually cancel out, so there shouldn't be a pi there. Okay, so I missed that right there. Now, going back to activity 3. So that's how they got this formula right here. Han uses the graph window below and sees the graph. All right, so if you want to graph this in Desmos, you can. Watch how they graphed it. All right, they put in, okay, 2 pi and then put in x squared. All right, plus 904 divided by x. All right, now if I want to change my window, I go to this wrench right over here. Okay, and then my x's, they ask for it to be negative 10 to 10. And then here they ask us to do this negative 2,000 to 2,000, like that. All right, and when I'm here, doesn't that look like the graph that they have on our paper right here? And it does. Okay, so now the question is, what is the domain and range? Well, remember, domain stands for X, range stands for Y. Okay, in this case, our domain is actually our R value. All right. Now, in this case, now think about it for a second. Do we want our radius to actually be negative? No. So I don't want this right here, but we want us to keep it in the positive. So it's going to be over here. Now realize this keeps going and this keeps going. Now my question is it ever going to hit this thing right here? All right, it actually is never going to hit that y-axis. And here's why. Do you see this r right here? Now think about a fraction. What can r not equal in the denominator? All right, it can't equal 0. R can't be 0 right down there. All right, so, but it appears that it can be anything else. All right, so our radius, okay, which is our domain, I'll just put D. Our R can be anything from 0 to infinity. Now, make sure you put a parentheses and not a bracket because we're not going to include it in there. All right, now as far as our range, okay, this is talking about our S value. All right, what is S? Now, if you notice right here, now we can't find it here. It looks like it's somewhere right in here. Okay, but when I go to Desmos, I can actually see it. Do you see that? And when you click it, you see this gray dot come up. We do have a minimum here. So what is the minimum Y value that our surface area is going to be? It's going to be 326.042. So 326.042 and up to infinity because it can get higher, okay, depending on what our radius is and what our height is and so forth. Okay. Now, I actually answered number 2. What would be a more appropriate domain to use in context? This one is the one in context to this problem. All right. Now, what is the range given the domain you choose? All right. And again, it's this right here. Okay. All right. Moving on. Okay. What I want you to do is I want you to go back to your packet and let's go to this page right here. Okay. You see some cards on this and we want to look at, and this is similar to those pictures that you were just doing just a second ago. We want to look at a series of cards and we want to pick out their domain and range. Now that was a word problem. Here we are going to deal with negatives here. We're also going to look at some other things that we've talked about previously. Now, some of these are going to be very difficult. Okay. Please understand that. Now, it is hard to read this So some of them I might not come up with, or some of them we just may be guessing when it comes down to Desmos in just a second. Now, but here, domain. Now, do you see there's things, and we're going to be talking about these. I can put a dotted line right here. These are things that X is not going to equal. And if you notice, that's at -1 and 1. So in our domain, X isn't going to equal -1 and X isn't going to equal 1. All right. Now, our range. Our range, I'm hitting everything down here in the negative here, and it appears I'm hitting at 0. But do you see how there's a gap in between here? Now, the thing is, I don't know what that minimum is. And let's see if we can kind of figure that out. The only thing I'm questionable about is what that number is in front of the x squared right there. So let me see if I can actually graph this right quick. Okay, so that's x to the 4th. Okay, divided by, maybe it's 2x squared minus 4. Okay, or maybe, nope, not that. Okay, 4. There we go. I think that's what it is. It looks like it's 4x. Okay, so look right here. We can actually see what that minimum is right here for that y value. And it looks like the y value is 1. So when I come over here and I do my range, if you notice right here, it's hitting at 0, 0. My y value 0 to 1 is what I'm skipping. All right, so my range actually goes from -infinity to 0. It equals 0, so I'm put a bracket. Then it equals 1, so I'm going to put a bracket there all the way to infinity. This is just skipping over between 0 and 1. Now, where is it increasing? Okay, now this graph looks like it increases from here to here, okay, from this minimum right here. And remember, we use x values. So from -1.414 to almost this x value of -1. All right, then it looks like it's increasing again down here. Okay, so that's on the other side of -1 to this point right here, which is 0. All right, but then it decreases. Okay, it's decreasing from -infinity to this x value of -1.414, that minimum right there. All right. Then it's decreasing again from 0 to this value of 1. All right. And then it decreases from 1 to this minimum value right here of the 1.14. All right. And then it increases again. I didn't write that one. 1.141 to infinity. Sorry, I'm going off into the other graph. Now, as far as in behavior, like here, that's as x goes to -infinity. On this end is as x goes to positive infinity. Here, f of x is going to positive infinity. F of x is going up to positive infinity. Now, we could talk about these other ends, but it gets a little more complicated. I'm just going to do the two on the far ends. All right, now let's look at this one right here. Domain, range, increasing, decreasing, and in behavior. Now this is a little more simpler. Okay, if you want to graph in Desmos, we can. And so let me throw this up here. That is, it appears to be x plus 3. Okay, ooh. Now, here's the thing. If I do divided by, do you see how it pops down? One of the things you might want to do is either put this in parentheses or highlight it and then say division. All right, -2x minus 4. All right, so that looks like our graph. Now, do you see right here on our graph, it appears that this is going up and this is going down. It's actually not touching this line right here. This is the line x equals -2. All right, so here in our domain, x doesn't equal -2. All right, now, does it appear that right here in our y, it's kind of doing the same thing? It's a horizontal line. I'm just going to give this to you if I put, and we'll be talking about this later, negative, it looks like it's at -1/2. All right, so here, our range, y doesn't equal -1/2. And we're going to be talking about what these are in these graphs later on. Now, as far as increasing and decreasing, think about when you're drawing this. You draw this and it goes up. You start here and this goes up. This entire thing is increasing, except for at -2. So what we do is negative infinity to -2, and then -2 to infinity. It actually never decreases. And the end behavior right here, as x goes to positive infinity on the right-hand side, what is our y going to? Well, this isn't going up or down. If you actually notice, our y value is going to negative infinity. And on this side, same thing. As x goes to positive infinity, f of x, or y, goes to this -1/2 value. Whoops, I put negative infinity. It should have been -1/2. It goes to that horizontal line that I just drew in there. All right, let's look at card C right here. All right, domain. Well, when I go here, I don't see any of those funky things where I can draw a dotted line. It appears that I can hit every x value right here, negative infinity to infinity. And if we want to try to graph this right quick, we can. Always in everything in this unit, please start practicing how to put some of these things in, because it will be, whoops, x raised to the 8th. All right, plus 1. They will start looking a little difficult. And I don't have any breaks here. Now, my range, now notice how my y values, that's the lowest and this is the highest. So it appears that my y values, my range is only going from -2 and I will move that in just a second, to 2.744. All right, like that. All right, now increasing and decreasing. So this decreases all the way to this point, and then it increases and then decreases again. All right, I don't know what those x values were, but let's go find it. Okay, so here I'm increasing only from this value, this x value right here, -0.784 to 0.784. That means on the ends from negative infinity to -0.784, I'm decreasing. And then 0.784 to infinity, I'm decreasing. Now we had a min. The min was right here, the one on the left. So -0.784 and -2.744. And then our max is 0.784 to positive 2.744. And then in behavior, if you actually look, this is going here and here. It looks like it's leveling off at 0. So here, as x goes to positive infinity, it looks like the y value goes to 0. And here, as x goes to negative infinity, it also the same thing, levels off at 0, the y value of 0. So it's not going up or down, okay, like our polynomial graphs. All right, let's look at card D. I got 2 more cards. I'm going to do D because I'm just going to do it in order. That's actually in your book on page 151. All right, so we got card D right here. What do you notice? And yes, there we go. Okay, what do you notice about the domain? If you actually look right here, do you see how we can put a dotted line in right there? Here, the domain, x just can't be negative 1, okay, of it. All right, it can't be -1 down there. And do you notice anything? You may or may not. All right. Now, this actually, there is a question here before we go to E. Which of the following rational functions has a domain of negative infinity to infinity? So if I were to graph this right here, x plus 2, I'm putting it in parentheses and then putting x minus 8. All right. All right, so look at it. Do you see how that actually has a dotted line right here? I could put a dotted line here. So here, x isn't going to be whatever that value is. It appears to be 8. All right, let me graph this. I'm going to take that off. I'm going to graph the other one, x plus 2 divided by x squared plus 1. And if you look, do I have any breaks here? No. The one that appears that would be negative infinity to infinity is this one. There's no breaks. Okay, there's no breaks here. I can't add in a dotted line like I have on those other ones. All right. And again, we're going to be talking about graphs later on. All right. One more. Okay. Card E right here. Domain. What is the domain of this one? Notice where we can put this, a dotted line at 1. So X can't be 1. It's not going to cross that line. Range. Now, do you see how this value keeps going down? This keeps going up. And then, but there's no break here because this end keeps going up. So it looks like our range is negative infinity to infinity. All right, now our relative min, if I do it off this graph, okay, so here, this is, it appears to be x cubed, all right, divided by 10x minus 10. Woohoo. 10x minus 10, like that. All right, so it looks like there's a min right here of 1.5 and then 0.675. I don't think there's a max. There's not really a max. This is just kind of the y-intercept right there. So we're going to say none. And then the end behavior. Here, as x approaches infinity, where's our y going? Well, this time it is going up to infinity. And here, as x approaches negative infinity, where is our y going? Our y is going to positive infinity because it's going up. All right, so there's those graphs. If you're a little confused about these graphs and everything, don't worry. We're going to be talking about them. Where did these dotted lines come from? We're going to be talking about that in the coming days as well. This is just an introduction into our unit, and this unit is going to be called rational expressions. All right. If you have questions, rewatch the videos, ask your teacher questions as well.